Hello Year 12 Maths Method students. In this video we're going to go through a couple of examples of differentiating the exponential function. And the natural exponential function has the neat, the amazing property that the derivative of e to the power of x is actually e to the power of x. In another video, which you might have already watched, we go through an exploration of the graph to kind of see why that's the case, but it is a fact that the derivative of e to the power of x is e to the power of x. Now obviously examiners are going to expect a little bit more of you than just being able to differentiate e to the power of x, so they're going to give you some more complicated exponential functions to differentiate. And in those cases, more often than not, what you're going to use is the chain rule. Okay, so the chain rule can be applied to anything that's more complicated than e to the power of x, which is most likely what you're going to differentiate. Before we talk too much about these two rules here, I mean, obviously you can read them in your own time, but let's go into example 14 and we'll use the chain rule to kind of see what we're talking about. Now, the chain rule, when we used it the normal way, not the shortcut method, what we would typically do is we would use u to represent something that seems a bit, to be making things a little bit trickier. So in example 14 here, it says differentiate e to the power of 3x minus 5 with respect to x. So if we're going to use the chain rule, let's say we're going to let u equal 3x minus 5. And if we do that, then straight away we get, or we can work out that du dx is equal to 3. The derivative of 3x minus 5 is just 3. And that substitution also says that our original equation, if we want to write it as y equals, would be y equals e to the power of u. And the derivative of e to the power of u is just e to the power of u. That's what we said at the start. So dy du is just e to the power of u. And therefore, when we use the chain rule and say, well, the dy dx, and this is just applying the chain rule, equals dy du times du dx, well, we're just going to get the derivative of 3x minus 5, that was du dx, so that goes here, times 3, and the other part was dy du, which was e to the power of u. Now, probably normally write the 3 in front, so 3e, and u was really 3x minus 5. So the answer to this is 3e to the power of 3x minus 5. Now, you might already sort of tell from the rules above or just from going through this that there's going to be a much quicker way of getting there. But this is just a nice kind of reminder, firstly, of like the slow way of using the chain rule, because sometimes that comes in handy if it's a complicated question and you're not really sure how it's going to work out. But it's also a really useful way of seeing why, when we differentiate exponentials, we can really take some shortcuts here, because if you were going to let u equal the power, you're always going to get this effect here, where your exponential function becomes e to the power of u, and that derivative is just e to the power of u again. So there's a really nice shortcut that we can take, and that is that we can say, and we're really using either one of these rules here, both of these rules just say, this first one says that the derivative of e to the power of kx, sorry, I should hold my hand here so the shadow's not blocking you, e to the power of kx, the derivative of that is just ke to the power of kx. Now, k that ends up in front is just the derivative of kx, so the derivative of the power has ended up in front as a multiplier. And this one says the same thing with just more complex notation. It says if y equals m times e to the power of f of x, so if your power is f of x, then the derivative is just going to be f dash of x, the derivative of the power, times, well, everything that was already there to begin with, m times e to the power of f of x. And so really with example 14, if you want to do it the shortcut way, and in reality this is the way you'll do it every time, all you have to look at is, okay, well, what's the derivative of the power? And the derivative of the power is 3. So that multiplies the original statement, which is e to the power of 3x minus 5. And there's your answer straight away. So the shortcut method for exponentials, dy dx equals the derivative of the power times the original expression. So example 15, let's do this the short way straight away. Well, x squared is the power. What's the derivative of x squared? It's 2x. So the derivative of 3e to the power of x squared is just 2x times the original expression. And, well, 2 times 3 is 6, so I guess we can go a step further here. Right, but you can see how quick that is once we recognize that all we're doing is just multiplying by the derivative of the power. And that's differentiating exponential functions. Enjoy.